Hi, everyone. Welcome. It's great to see so many people getting up and joining us for this symposium today. I'm going to get my notes here. Just give me 1 second. Okay. The first thing I want to do is to welcome you on behalf of the PSR, the Pacific Southwest Region University of Transportation Center. My name is Genevieve Giuliano, and I am the director of PSR as well as the METRANS Transportation Center. I want to start by just assuring you that it's not going to take me 15 minutes to welcome you all. So you should all have time to grab that extra cup of tea or coffee before we start our first session. Just to give you a little bit of background, PSR is a consortium of 8 colleges and universities, USC, UC Davis, UC Irvine, UCLA, Cal State Long Beach, University of Hawaii, Northern Arizona University, and Pima College. METRANS here at USC serves as the lead for PSR. And as most of you know, METRANS is a multidisciplinary research center that was established way back in 1998. So we have passed our 20th anniversary, and before we know it, we'll be looking forward to celebrating the 25th. PSR was established about 5 years ago under the Federal Surface Transportation Act, called the FAST Act, of 2016. And one of our objectives, of course, is to promote excellence in scholarship so that we produce graduates with state-of-the-art knowledge and tools. I'm really delighted to have so many attending to hear the best of our best Ph.D. students from throughout the consortium presenting their dissertation research. This is our 3rd Emerging Scholars program. It started with our realization that we actually had more dissertation research going on than we had seminar slots to allow them to be presented. So we thought, why not just make a day of it? Give our students the opportunity to present their research to a larger audience, to allow them to meet one another and network, and also hear from some of the leading researchers and innovators in the field. Our experiment turned out to be a great success, and the symposium now is one of the great outcomes of the PSR Center. So it's one of our flagship activities. Of course, COVID had other plans for us this year. So our one day is this time 2 mornings, as nobody should have to sit in front of a Zoom screen for more than a few hours at a time. The format is working out. We have 4 paper sessions and a total of 10 presentations. We also have 2 very distinguished speakers. You will hear from my colleague Susan Handy today, and then you'll hear from former Senator Fran Pavley tomorrow. Professor Handy is one of our leaders in sustainable transportation research, and Senator Pavley has been an ardent advocate of climate change mitigation policy and was one of the architects of AB 32. USC, UC Davis, UCI, UCLA, and University of Hawaii have PhD programs, and I'm very pleased to say that we have representatives from all 5 universities at this year's symposium. So I guess there is an upside to Zoom. The students presenting today and tomorrow are our brightest, best trained people. They're the innovators, creative thinkers, and problem solvers. They come from several disciplines, including urban planning, transportation science, civil engineering, electrical engineering, industrial and systems engineering. This array of disciplines reflects the nature of transportation. It's certainly a field that's very broad and multidimensional, and we need research from all of these areas to make transportation better than it is today. Before we get started, I want to thank the organizers of the symposium. Vicky de Guzman, who you can't see, but is here, is our Associate Director of Education and Professional Development, and she leads our student engagement programs. She has organized a stellar team of students, and I hope I have everyone on this list. These are the students who actually have organized and are managing this, the symposium. That includes Ashley Jimenez, Zoe Lee, Dan Lamar, and Marley Randazzo. They have created symposium materials, blah, blah, blah. I can't talk anymore, and participated in all of the detailed logistics that this type of event requires. This event, no doubt, will go smoothly from beginning to end because they're all such excellent organizers and workers. The team also includes Katrina Soriano, who is our METRANS administrator, and among her other duties has now become a Zoom webinar expert, and she's the person who started the webinar today. So before we get started, please join me in thanking the entire team with some virtual applause. We're going to have 3 papers. The title of the session is Transportation and the Environment. We're going to have 3 papers. 2 papers are kind of in the same structure. The 3rd paper is quite different. So I'm looking forward to a really interesting discussion. I think that you all are going to be very impressed with the breadth that you're going to hear just in these 3 papers as we go forward. Each speaker has something less than 20 minutes so that we can allow for time for discussion. We will probably have discussion at the end rather than trying to squeeze it in between the papers. So we're going to start with Yougeng Lu. Yougeng Lu is a Ph.D. candidate in urban planning and development here at USC in the Price School of Public Policy. His dissertation work is on the relationship between environmental pollution and exposure and the distribution of exposure across different socioeconomic groups. So a good portion of his research is aimed at social justice, environmental justice. So we will start with Yougeng, who is going to present estimating hourly PM 2.5 concentrations at the neighborhood scale using a low-cost air sensor network, a Los Angeles case study.
Thank you, Professor Giuliano, for introducing me. So I'm Yougeng Lu. I'm now a 4th-year PhD student at USC. And my research, my presentation topic is estimating hourly PM 2.5 concentration at the neighborhood scale using a low-cost air sensor network, a Los Angeles case study. This is actually a part of my dissertation, and it's advised by Professor Genevieve Giuliano and Professor Rima Harper from Keck School of Medicine at USC. They are also the co-author of this paper, and this work has been published in the journal Environmental Research. So, as we all know, air pollution is a major public concern. It has adverse effect on human health, and it can cause various diseases in both short-term and long-term, such as stroke, asthma, and lung cancer. There are many factors can contribute to air pollution, like traffic emissions, natural emissions, and industrial emissions. These are 3 major sources of air pollution. Besides, other factors like meteorology and topography can also affect the distribution of air pollution. So for planners and policymakers, what can they do to mitigate or reduce air pollution? For me, I think planners can help at least from 2 perspectives. One is to improve the air quality monitoring, and then the second is to develop some target policy and plannings to protect public health. So air quality monitoring is very important because it provides direct indicators that reflect the air quality conditions. So accurate air quality monitoring can help planners understand air pollution distributions and also develop more targeted policy and regulations that protect public health. Besides, we also like air quality monitoring to be at real time and at neighborhood levels. The real-time air pollution monitoring at neighborhood level is beneficial to provide guidance on short-term outdoor physical activities for local residents. So in this study, we focus on the 5 particulate matter, also known as PM2.5. And our major research object is to estimate PM2.5 distribution pattern at the neighborhood and hourly level, especially at unmonitored areas. So why do we care so much about the PM2.5 prediction at a high spatial temporal resolution level? Because we think we want to study the association between exposure PM2.5 and acute health effects. And we also think this high spatial temporal resolution PM2.5 prediction can help planners at neighborhood environmental plannings and designs. And also it can provide local residents guidance on short-term outdoor physical activities. So in this study, we choose Los Angeles County as our case study. Los Angeles County is one of the most polluted areas in the US, and also the LA metropolitan area is the second large metropolitan areas in the US. So different from the previous research on predicting air pollution, we are using the PM2.5 data from a low-cost air sensor network called Purple Air, instead of using EPA monitors in this study. So both EPA monitors and Purple Air sensors collect PM2.5 data. And compared to EPA monitors, Purple Air sensors is much cheaper and require little training to operate it. So most people can afford to purchase Purple Air sensors and install them easily in their backyard to monitor air quality in their neighborhood in real time. So the low cost of these Purple Air sensors make it possible to measure air quality in more locations. There are 361 Purple Air sensors in Los Angeles counties, while only 12 EPA monitors at the same areas. So all of these advantages make Purple Air sensor a better choice if we want to predict PM2.5 at the neighborhood level. However, since the Purple Air sensors are not designed for regulating purpose, their data quality is not as reliable as EPA monitors and may be easily affected by different weather conditions. But recent evidence have shown their performance is keeping improving in the last few years. So in this study, we convert the PM2.5 data to hourly levels and collect the data from Purple Air sensors from January 1st, 2018 to December 31st, 2019, totally 2 years. And as I mentioned before, because the PM2.5 data from the Purple Air sensor is not that reliable, so we make some quality control process to clean the data before we do the prediction models. So we only keep the sensors with more than 75% data available, and we delete some extreme readings. And for each Purple Air sensor, there are 2 channels collecting the PM2.5 at the same time. So we compare 2 channels readings and delete the channel, the sensors with mismatch. So we also divide our study areas to 500 meters multiply 500 meters hexagon grid. And in the final, we have get a little more than 2.5 million valid hourly PM2.5 readings from purple air sensor. So as I mentioned before, many factors can contribute to PM2.5 concentration and distributions. So we control as many variables that is informative to impact PM2.5 concentrations as possible, both spatial and temporal varying variables. So we we control for the spatial temporal autocorrelations, the background PM2.5, which is from the EPA monitors, and then the valid conditions, land use variables, traffic variables, and we also control the temporal dummy variables to control for the monthly, hourly, and also the seasonally variations in PM2.5 concentrations. And in the final, we have 101 predictor variables in our prediction models. So in this study, we use a machine learning-based algorithm called random forest method to develop the PM2.5 prediction model. So the right graph just shows the structure of a random forest method. So you can see for the random forest, we first divide our samples to several sample subsets, and each one called decision trees. So we have multiple decision trees in a random forest. And for each decision trees, it will develop its unique prediction models. And our final prediction is the combination of all the prediction results from all decision trees. And finally, we can get our random forest prediction. The advantage to use the random forest method is when compared to the traditional linear regressions, it can control for the nonlinear relationship between dependent variables and independent variables. And also random forest is very effective and productive at dealing with the big data issues. So in this study, we set the number of decision trees to 200 and the candidate feature attribute number to 30. And to validate and test our prediction performance, we also apply a tenfold cross validations to test our performance. So the mechanism of the tenfold cross validation is we divide our sample to 10 groups, and we use 9 groups to be our training group and then the last one as our test group. So we can get the test results for our prediction performance. So in this study, we run the overall cross validation and also the spatial cross validation, which we divide our training and testing group based on the spatial clusters, and also the temporal cross validation, which based on the hour. So this slide shows the results of our prediction models. So you can see the y-axis is the predicted PM2.5 from our models, and the x-axis is the measured PM2.5, which is the real PM2.5 readings from the purple air sensors. And the color bar shows the densities of our the point. So the blue lines here is the 45 degree lines, and then the red dashed line is the fitted line from our models. So the R square equal to 0.93, which is very high numbers, and the RMSE is 3.23. which is relatively low when compared to our PM2.5 concentration. So this result shows our prediction models has a high prediction accuracies. And we also found a high predictive abilities of our models in space and time. For the spatial cross-validation, R square is equal to 0.88. And for the temporal cross-validation, R square is equal to 0.90. Both are very high numbers. So we just want to show the visualization of our prediction performance. So first we select one weekdays and one weekend days. For the weekdays, we choose the Wednesday, September 18th in 2019. And for the weekend day, we choose this, the Sunday on September 22nd in 2019. And we shows the PM 2.5 distributions for 2 different hours, at the morning peak hour at 9 a.m., midday at 2 p.m., and then the evening peak hour at 6 p.m. and the late night at 11 p.m. So we can see on the peak at the morning peak hour, we can see a totally different PM 2.5 distribution on weekday and weekend. So for the Wednesday, we see a higher PM 2.5 concentrations and a more dispersed PM 2.5 distributions, especially along the highways. And at the Sunday, at the morning peak hour, we see a lower PM 2.5 concentration and a more concentrated PM 2.5 distribution at the urban areas. And then when we look at the late night, we can see on the weekend days, we see a higher PM 2.5 concentration and a more dispersed patterns. And at the weekday late night, we see a lower PM 2.5 concentration and more concentrated. So we assume that's because at the weekend night, late night, there are more traffic. And we also did the service prediction for wildfire days, which is happened on Sunday, November 11th in 2018. So it's during the Uzi fire, which happened near the border of Los Angeles counties. So marked in the black circles. So we can see from the color bars, for both 4 hours, we can see a very high PM 2.5 concentrations across our study areas, especially at 9 a.m. So we assume the PM 2.5 distribution is mainly affected by wind. So we can see the wind rose map here. The PM 2.5 concentration is much higher when there's northeast wind and at the southwest region of our study areas. And then we also did a service prediction for a holiday on an independent day in 2019. And it's easy to find. We found a very high PM 2.5 concentration at late night at 11 p.m. We assume it's because the recreational fires and the firework at late night on the independent day, which caused a high PM 2.5 concentration at 11 p.m. So from our study, we think the low-cost sensors can supplement the conventional EPA monitor network to estimate more spatially and temporally resolved air pollution. And also, we think the predictive models can be used to capture some spatial and temporal patterns in PM 2.5 on less frequent and more extreme conditions like holidays and wildfire days. And also, these prediction models enable the highly resolved and improved exposure estimation in study of acute air pollution, health effects, and the study of environmental justice issues. And we believe this model can help planners and policymakers with neighborhood environmental plannings and designs. And also it can provide local residents guidance on short-term outdoor physical activities. So that's all of my presentations. I'm more than happy to take any questions.
Thank you very much, Yougeng, right on time. Our second presentation is Sue Dexter, also a PhD candidate in urban planning and development in the School of Public Policy here at USC. She has been working on another aspect of sustainable transportation, and that is zero emission heavy duty vehicles. And so her presentation is going to be on operational consideration of zero emission heavy duty trucks, perspective from the trucking industry. One of the things that we learned in doing the research is that much of our predictions and much of our expectations about moving to a zero emission fleet doesn't really think about the effects on the trucking industry. So Sue's effort here is on figuring out what happens in freight operations and how we can figure out better strategies to make it possible to move into much less polluting heavy-duty trucks.
Well, thank you very much for that introduction. I'm going to be, as Dr. Giuliano said, I'm going to be talking about the operational considerations for heavy-duty trucks. And specifically, we're going to be looking at the Los Angeles area. But I want to explain that this was part of a larger study for the AQMD that investigated market potential for heavy-duty zero-emission trucks. And the study itself had two different elements. Determining the impact of these zero-emission trucks on costs and GHG emissions, as well as studying the fleet operational impacts. And so this actually looks at the latter part, and it's become part of my dissertation. So before I even get started on anything else, the whole research team is listed on the right-hand side here. Dr. Giuliano led this, the entire effort. But the person that I worked most closely with is Jane Fang. And I don't think Jane's on the line today. I invited her, I wanted her to come. But so she helped with all the data analysis and all of that. She is a master at data manipulation, to be sure. So, but the research questions that we wanted to address is, can the zero emission heavy duty trucks handle operational requirements of firms? So of course, when we're looking at these types of firms that use these heavy duty equipment, they have certain demands. They have to deliver things on time to their customers. They can't have a lot of downtime. Those kinds of things. So, they have to be able to fit into the way that they need to do business to make a profit, to continue to operate. So, what are the hurdles for the firms to embrace the technology? And some of the other things that we wanted to find out was what are the experiences and perceptions by the fleet operators? And then would they even consider buying one of these? So we approached this from two different fronts: interviews, the in-depth interviews of fleet managers, and then case studies. We also did another preference survey, but I'm not going to talk about that. That was actually handled by Dr. Steinmetz and Dr. O'Brien from Cal State Long Beach, but I'm not going to include that in here since I wasn't involved with it. So before we move on, I just wanted to lay the groundwork and quickly review the landscape for truck traffic use in Los Angeles. So we see the Los Angeles central area, including the Inland Empire. And as we would have expected, but we ran the data to make sure that it corresponded with what our thoughts were, is that there's three major clusters of freight activity in the LA area region. And so one is near the port, so that's down here at the bottom, through the corridor up through San Rancho Dominguez area. And then the second one is near the Los Angeles downtown area and Hobart Intermodal Rail Station. And then the third one is out here in Rancho Cucamonga in Ontario, where if you've ever been out there, it's just called the land of warehousing, really. So when we overlaid, this map actually has three different overlays on it to create these hotspots, and it has the the truck trip intensity, and it also has employment for warehousing and those things. So anyway, we wanted to focus on the drayage activities, which coming out of the port is about 16 to 20,000 containers a day. And that's truck traffic that's coming out of that area. So you can only imagine, if you've ever been on the 710 freeway near that area, it's kind of scary sometimes. So that is our landscape about what we're looking at. So first of all, I wanted to talk about the interviews that we did. And so the objectives were, how familiar are the drayage operators with alternative fuel trucks, and what, if any, reservations did exist for them? So I sat down and had quite lengthy interviews. It was a semi-structured interview, but then I did let them tell me other things that they wanted to tell me about as well. But as you can see from the chart at the right, some of the concerns that they had were mostly truck costs. Now, these alternative fuel trucks, there's not very many of them out there right now. And just like anything with economics of scale, they're very expensive. They can be 3 times as expensive as a regular diesel truck, and they have a lot less performance capability. So there's pretty much high hurdles to get over with these. So the truck cost is the number one. Followed by the charging equipment cost, which is also very expensive that they would have to put in at their fleet operations. The charging time for actually powering up, if it's battery electric, performance issues. Unfortunately, there got a lot of press that some of these vehicles, they ran out of juice on the freeway and had to be towed. So that was actually mentioned by quite a few firms. So one of the firms actually was involved in the demonstration. So there's lots of money being pumped in for generations from the state of California to do some technology forcing on the part of these OEMs to get these trucks out there tested for operations. So, but the key point is that 67% would consider purchasing if costs were not an issue. They really do want to do things that are right for the environment. But the big issue here is that the minimum range that they would need to have these trucks to go is, on average, was 287 miles. And right now it's between 70, 100. At the very long set, it's like 130. Some of the new Volvo trucks are like 150 mile range. So, and that's a lot compared to the 70 miles. So a lot of different things. So range, I was expecting to be much higher. And as you can see, it was only 67% was on their concerns. But anyway, so then when we start talking about the case study here, the case studies that we did were looking at 2 firms, and they couldn't have been more different. They were, the first firm was chemical, liquids, and dry bulk, where the second firm was natural food delivery. So yeah, you can't get more different than that. The first firm owns all their trucks. The second firm leased all their trucks. The first firm operated only 1 shift a day. The second firm operated 3 shifts a day on most things for a truck. They really ran those leased trucks. And firm 1 had a different type of, they use their own employee drivers plus owner operators, which are contract workers, whereas the other firm 2 only had their own drivers. So you can see that we couldn't have picked 2 different firms. So before we get into what the data is, I need to tell you about what our assumption was. We were saying that our assumption is that they can only charge at their yard location, and they'll charge once a day, and it will be 4 hours for charging, and they can come back and they can do a tour. So an individual trip would be going between each of these nodes, and a tour would be coming from the charging equipment all the way back to the charging equipment again. But of course, they couldn't charge during the middle of the day because that would take too long. Okay. So the data that we collected here, we had 2 months for firm 1 and only 1 month for firm 2. We collected data every day for every single stop they made during the day, of geolocational data, so we could actually make maps of that. We had load weight, load type, truck type, and then the distance in miles. Some of these things we actually had to create based upon the data that we were given. Some of the things that in the actual weight, we had to make some assumptions on that. If the weight was more than 0, we assumed it was a fully loaded container. And if it was equal to 0, we assumed it was an empty container. And just to let you know, these things, they're heavy, just even when they're not loaded. We assumed that they were 40,000 pounds with the BEV tractor and empty container. And they can take up to 80,000 pounds on the road. So one of the things that weight is important is because of the fact that that makes you have to pull more, which means you have to use more juice to make it so. So that was an important consideration for us. So just to let you see very quickly here what the locations of the customers and where they were going on the day, you can see that for firm 1, there's in those 3 clusters, right? So Long Beach area up to LA, out to Ontario area, and then some other hot spots. And then looking at their data here is really interesting because, like I said, a single tour distance is going from their home base back to their home base. But they had many of those a day. I think that for this particular firm, it was 3 per day. But it's the daily distance that we're really looking at, right? If they're only charging once a day, it doesn't matter if they're coming back without being able to charge. So we come here and we see that the daily distance, more than 120 miles, is 56% of their trips on average for that day, for that month. And this was for October 2018. So for firm 2 had a different type of distribution. And again, they're making a lot of different stops because they're delivering food to grocery stores, and they're going all the way actually down to the border in San Diego. So a little bit different, and then they go all the way out past Palm Springs and on the 10 freeway out towards that area. Then you can see here that they actually go on a daily distance farther than 120 miles, but they're also using their trucks for a longer period of time during the day as well. But this has very different distributions. So keep those things in mind. So the summary of the distances here, again, for firm 1, for the daily distance, here for month 1 and month 2, a little bit different for each one of those, but still around 50%, and firm 2 is 66%. And as I was talking about, these vehicles are not the BEV vehicles anyway. They're just the new ones are going more than 100 miles with a full not a full tank of gas, but a full container load, right? So getting to this particular slide, this really shows what if they were going to be looking at purchasing a truck at the current moment in 2020, what percent of their workload based upon all these trucks that we were looking at, and we did look at every single truck that they were running in their fleet for this period of 1 month, what percent could they run? And so we utilized the battery capacity, which was used in the simulation study, which was the first part of the study itself. So we were joined with those particular results for 2020, 2025, and 2030. And you can see here that without weight limits, that they could run right now, firm 1 could run 30% of their business, but with weight limits, 18. In 2030, it jumps up because of course, the battery capacity and the efficiency is supposed to get much greater. But if you get down to firm 2, it's dire, especially in 2020, because of the fact that this was a lot not driven by there was a little bit of a difference with the weights, but it was mostly driven with the time that they had to charge. Their trucks are on the road all the time. They don't have those 4 hours. So it's not until you get the range that's available here in 2030 that they could even consider it without the weight limits. But even with the weight limits, this particular business would have to change the way that they do their operations significantly to make this technology work for them. So the conclusions here is that the drayage market, it couldn't be so very different. There is so many different types of firms delivering different types of commodities. And so we need to actually look at particularly certain aspects of the drayage market to get these vehicles in first off. As I mentioned, that battery electrics are heavily influenced by range and weight. So as we can get these batteries much more efficient, that's really is the key to adoption. They are making a lot of progress. Early adopters can cherry pick those particular tours. Maybe they can pick out those particular, like I said, the 18% that they could actually run. What are those 18%? But one of the big things is down on the bottom here is many institutional operational barriers. If you have owner operators that only have one truck and they're given a certain route for the day and they can't handle that route, then basically they don't have work for the day. So they can't cherry pick their routes. They can't cherry pick potentially their work. So this is something that CARB and is really looking at as well, is how this particular technology is going to affect this group of people. Also, where are they going to charge? Where are owner operators going to charge if they can't charge at a fleet location? There aren't any right now. There's no charging infrastructure out there in the field for trucks. There might be for cars, but it's a very different circumstance. So the next step really is to add additional firms. I got some more data for a firm, and so I'm going to start doing this for another firm. And we'd like to also look at this from hydrogen and natural gas hybrid trucks as well. That is what I have to say. And I know that Dr. Giuliano wants to, I think, do we want to do Q&A now or later if there is any questions?
So I know you mentioned weight was a concern with batteries on these trucks. I'm just wondering if there's been any kind of conversation in the policy space about the impact this could have on roads and road networks.
That's a really good, that's an excellent question, because of the fact that right now, 80,000 pounds is the limit for a Class 8 truck on the roads, due to damage of the roads and those kinds of things, because that's pretty heavy, right? The battery itself and what we utilized in this study as far as our assumption is, I believe we used 5,000 pounds as the weight of a battery. But batteries actually for the demonstration trucks are varying up to like 7,600. I even saw one for 9,000 pounds. So if you're looking at that 80,000 pounds, what does that mean? That means if you have to keep it within the 80,000 pounds, that's less payload that you can have too. So that even decreases the efficiency of the operations even further if you are fully loading up your vehicles. Like the firm one, the chemical firm, they run heavy because that stuff is heavy. Now the food folks were not necessarily always filling up weight-wise on their truck. It might be actually cubing out, but not weighting out. So that's something. However, that they have recognized that this is an issue, and so they're saying from the state perspective anyway. And I only know about California. But California is more advanced in doing these demonstrations and everything than the other states are at this point. So if increasing the amount of weight that a truck and their payload can be over 80,000 pounds. But I don't think that they've come to a determination about what that weight is. But it can't go up too high because, the loads on bridges and some of this other stuff. So anyway, but great question. It is being discussed though.
Thank you, Sue. Two very good presentations. We're going to change directions with a third presentation. The two presentations you've heard are very much empirical studies, you might say close to in the weeds, right? Very detailed studies on very detailed issues. that help us to understand the larger policy context and what we might do about it. Our next presentation is very different. It's going to ask us to think and to think about transportation in ways that I think we don't normally consider. And so this is Theo Wickland. He's a PhD candidate in urban planning at our neighbor, UCLA. And he's going to talk about pluralizing transportation epistemologies.
So hi, I'm Theo Wickland. I'm a PhD candidate in urban planning at UCLA. So a bit about myself by way of introduction. I did my undergraduate degree in physics before working in business and technology for several years. I later decided to change careers, partly because I was disillusioned in working for capitalist companies that didn't seem to be doing anything to make the world a better place. I chose to switch careers to transportation because I wanted to help make transportation more sustainable and equitable, and I wanted to help develop transportation spaces as social spaces for meeting and interaction. But in my master's studies in transportation engineering and city planning, and in my work on university research teams and at local government agencies, I learned that the ideas that seemed incremental to me seemed radical to other people. So for example, I wrote my thesis on transportation planning for Polk Street in San Francisco. It was a street where over 8 walked, but most of the space was allocated for cars, and it had one of the city's highest concentrations of serious crashes between cars and pedestrians or bicyclists. So I thought, let's turn the street into a great place to walk, make it a linear park, add some bike lanes, maybe even take the historical stream that's been turned into a storm sewer and put it back on the surface. Wouldn't that be a great place to walk, to shop, to hang out, to be alive? Unfortunately, not many people at the Municipal Transportation Agency seem to agree with me. They contented themselves with proposing bike lanes and some bulb outs. And when the merchants complained about parking spaces being not even lost, but just moved around the corner, well, the agency canceled one of the bike lanes. And so then there was only a bike lane in one direction, plus the pedestrian and bus bulbs. So it was a very incremental project. I spent a year after graduation working for that transportation agency, and I saw what seemed to me like an immense lack of creativity and imagination, rocking boats at City Hall or among influential local interests. So I said, let me go and do a PhD and study planning. How did we get to this place where all we can do is add a few bulbs and one bike lane, when much more transformative change seems totally rational and to me not really radical at all? So what I'm here to share with you today are some of the research and findings that have come out of that project after some twists and turns along the way. To give you an overview of my presentation, first I'll introduce the framework of my research, how I position it with respect to other research in transportation studies, and concepts related to epistemology and technoscience. Next, I'll explain what I'm trying to get at with the idea of transportation epistemologies, and share 3 illustrative examples, and then finally conclude with a summary and recommendation. So without further ado, I define 5 contrasting axes that the research focuses more on policy and technology or on questions of culture and ideology. The second is a focus on technological solutions on the one hand, or on critical theory on the other. The third axis contrasts quantitative and logic-based research with qualitative and storytelling-oriented projects. Next, research that embraces modern scientific epistemologies. I'll define epistemologies in a moment, as compared to research that emphasizes more plural and subversive epistemologies. And finally, research that usually unintentionally reinforces or reproduces systems of modernity, coloniality, and extractivism, versus research that deliberately attempts to undermine that. So much research in transportation studies is on the left end of these 5 axes. Not all, I'm generalizing here, but we have a lot of research oriented on policy, technology, technical solutions, which is quantitative, uses scientific logic, and unfortunately tends to reproduce colonial and extractive relations. I'll describe those in a moment too. On the other hand, I have in my research to do the exact opposite, to focus on questions of culture and ideology, to engage critical theory, and to emphasize storytelling, all while engaging plural and non-standard epistemologies, and hopefully undermining modernity, coloniality, and extractivism. So now, as promised, what is epistemology? Epistemology comes from Greek roots meaning knowledge and know-how. In modern English, it may mean the study of knowledge and how we acquire knowledge, or it can refer to theories about knowledge, or finally, and this is the main way I use the term, it can mean a way of knowing, a way of acquiring knowledge. So I'm going to relate epistemology to something called technoscience. And to do that, we'll go through a few more definitions. I swear these are the last definitions I'll be offering today, so hang in there. I conceptualize knowledge as stories, and specifically stories. Science is a name for any system for developing new knowledge based on observation and experiment, which is not the same thing as modern science, which is much more specific. Modern science is a particular local knowledge tradition that comes from Europe, and it's based on the idea that scientists are separate from the objects they research, which brings us to technoscience, which is the process through which we embed modern scientific knowledge into technologies, which is, in the case of transportation, might include infrastructures, vehicles, transportation regulations, and so forth, even including institutions like transportation planning and engineering professions, and the universities that lead related research, So yes, technologies here are not just physical things, but also social and political structures. Okay, so now that I've given some definitional overviews, we can talk about why I was motivated to focus my research on transportation epistemologies and why I think others should research transportation epistemologies as well. First of all, transportation systems have a lot of power. The way transportation works affects our social and economic situations, and the way we move around affects the experiences that we have, and therefore the knowledge we gain through that experience. They also structure the way we relate to nature, and therefore how we identify ourselves in the context of the planet we live on. Second is this issue of modernity coloniality. This frame comes from post-colonial studies and basically says that European modernity, on the one hand, and colonial style political and social systems, on the other hand, are actually one and the same. And these systems are about domination by supposedly superior groups over supposedly inferior groups, and developing standards that are uniform all over the world by forcing the ostensibly inferior groups to adapt to the ideas and cultures of the ostensibly superior groups. You see this all the time in socially constructed oppositions like rich and poor, men and women, developed and developing countries, people of color, so on and so forth. The problem is that transportation systems are implicated in this broader system of modernity coloniality, which is where transportation planning and engineering come in. We don't really do it on purpose, but we often unwittingly protect modern colonial institutions by using technical approaches and identifying standard universal solutions. But it's not all doom and gloom, because there's a hopeful side, which I refer to as abundant futures. Abundant futures is an idea that comes from environmental studies, particularly discussions around the Anthropocene. And it's an idea that we can fight for futures based on mutually supportive flourishing. And in these futures, rather than imposing standard knowledge, which is a sort of universal story, we can facilitate new and radically diverse storytelling. And all this will unlock new possibilities of emancipation and fulfillment for everyone. All right, let's get into the nitty-gritty. So just to illustrate, transportation science runs along a spectrum which might, on the one hand, facilitate diverse mobility cultures, and on the other hand, impose modern universals. From my dissertation research in French Polynesia, here's an ancient road in Anaho on the island of Nukuhiva. This road has been here for hundreds of years and was built by the ancestors of the people who live in Anaho today. So people who maintain the road are not just facilitating movement, they are also communing with their ancestors. Here is a road on the island of Mopiti. It's wide, flat, and made of concrete, but it's pretty well integrated in the local landscape. The same color and actually about the same texture as the broken coral on either side. And it's just wide enough for everyone to move slowly around the island, which is most often on bicycle, but sometimes on foot, on Vespa-style scooters, or in cars and pickup trucks. And here is some transportation infrastructure from Tahiti, where you can see everything has been pretty much leveled and paved smooth, lots of barriers, it's prioritizing cars, and pedestrians have to climb up and over the highway to get to the other side. As another example, I'll take you to southwestern France in the land region, where local people historically walked around on stilts. So hopefully you can see in this picture, there's a guy on stilts leaning against a tree at the edge of a bog. And the stilts were really adapted to this environment. This picture is from the 1800s. At the time, folks in this region often and most commonly use stilts to walk around through the bogland. But with modernization, France tried to make transportation in the region more standard. So here's a dry graded road running in front of a new post office in the same region at around the same time. And they were really trying to get rid of stilt walking because they thought it was backwards and uncivilized. And today, transportation in the land has the same standard infrastructure we have everywhere. They drain the bogs and basically force people to give up stilts by taking their land and mocking stilt walking. And so now instead of stilts, you move highways like almost everywhere else in the world today. And so the flip side of that transportation technoscience is the transportation epistemologies, which both shape the technoscience, but also flow out of it. During my dissertation research, I went for a hike with some local friends on the island of Motiti. And it's like scaling the mountain. Most Americans would think to wear hiking boots or something like that, but local people go barefoot. And actually, our feet, human feet, are well adapted to walking, especially when you go barefoot a lot from a young age. So I was wearing sneakers. I've always lived in the US until for the past few years. I was sliding around and almost falling on my butt more than once. But my bare feet were gripping the ground and not sliding at all. So going barefoot is actually a way of knowing because of how you experience and interact with the earth and the ground. And it teaches you how to grip and walk so you don't fall. Some other of my friends on OPT often climb trees to collect coconuts or get fruits. And climbing a tree for them is like walking down the street. It's just totally natural. It's just another type of transportation. And that's also a way of knowing space and your relationships to nature in a different way. What about bikes? Well, bikes are modern, but you can do different things with them, like rocking wheelies. Rocking wheelies is not about getting from point A to point B. It's about something else, like exuberance and being alive and marking space, or this person with their child standing on the bike behind them. It's another way of knowing transportation and knowing how to move, even though they're appropriating modern technologies like bicycles and paved roads. So let's get a little bit more modern, looking at scooters. Even there are different ways of knowing and relating. Here's a guy on the left parking his scooter in his marijuana patch and another in a paved lot outside a modern supermarket. These are totally different ways of relating to space and also relating to transportation destinations, but they're both running errands on scooters. So now think a little bit more about how standardized and rigid this type of bike infrastructure is that we see often in the US. This image is actually from NACDA, so it's like expressly a standard. Or even driving a car to the airport, for example, it's a bit less of a modern universal thing and more of a genuine human cultural experience to get dropped off with a hug by a loved one versus paying a stranger to deposit you. When we walk in stiff shoes on pavement, it tells you almost nothing about the space and place you're in. And freeways are one of the quintessential modern universals where we're totally separated from the land and just engaged in speed and pure movement and efficiency in reaching a destination. There's no wheelies or touching texture or any of that. So before I close, I'd like to meditate on 3 examples which illustrate what I'm talking about a little bit more. The first example regards how engaging transportation systems shapes the way we know the world. So on the left is another bit of the informal road from Anaho that I showed earlier. And on the right is a standard highway, which could be almost anywhere in the world. And what we see on the left is local people have appropriated modern technology, concrete, to maintain and care for their ancestral road, which by the way is the only land route to their valley. And people walked on the concrete before it was dry, literally marking the road with their presence. The road is suitable for horseback riding, mountain biking, and walking. It's exactly what local people need and want from transportation. And it has so much meaning for them because they own it. On the right, we see that the government has come in and engineered a standard highway, which tries to be as uniform as possible, with markings referring to a standard set of rules like no passing, which if you break them can land you in trouble with the police. The meanings and ways of knowing that are embedded in the road and that you learn from using the road are totally different. A second example about some of the unintended consequences of modern transportation shows how we can understand transportation systems in different ways. In the Marquesas Islands, which includes Nuku Hiva, for example, there were no mosquitoes prior to the 20th century. It was a visit from the German military early in the century, which inadvertently introduced mosquitoes. And now they are everywhere. They're a massive pain in the butt, and they also transmit diseases like dengue fever and chikungunya. Closer to home, in the US, we have trucks inadvertently spreading salmonella. And in this past year, we've seen global air networks create a global pandemic, like supply chain disruptions. So these are different types of unintended relationships produced through transportation, which also help us to better understand transportation. My third example concerns the role of transportation systems as a mode of analysis. So I will focus on the system of extractivism, which is basically a lens for modernity coloniality. And transportation is a key part of that system. Transportation here allows us to understand extractivism. In this system, we have militarized police who guard against and attack residents and demonstrators so that corporations can build and operate infrastructure to extract, transport, and refine fuels, which are then sold for use in transportation, ensuring that rich people get richer and transportation systems pollute our relationships with nature and each other. For example, leading to police harassment and killing of disfavored groups, and more police repression, as well as adverse health and the accumulation of toxic and non-biodegradable waste in a linear one-way process. So in this case, we have transportation as a system which can help us to understand extractivism. And there you have it. So to recap my presentation, I began with a critique of transportation scholarship. I find that transportation scholarship often ignores cultural, ideological, and political factors in order to define problems as technical and to focus on technical solutions. Transportation epistemologies are a new approach that take the opposite tack. Using the lens of transportation epistemologies, we may observe that transportation technoscience embeds modern colonial epistemologies in transportation systems. And these epistemologies then shape our ways of knowing, relating, and valuing whenever we use or even observe transportation systems. Finally, transportation systems are themselves epistemologies that may be applied in social, cultural, political, and economic phenomena. I will conclude with some suggestions for both researchers and practitioners. First, I would encourage researchers to pay much more attention to often hidden cultural and ideological contexts, which are not neutral or technical, but in fact political. Second, researchers should focus on promoting cultures and ideologies that emphasize love and generosity toward people and nature, and propose transportation changes accordingly. Third, as for practitioners, I think the most fundamental is to recognize that transportation is not technical and it is not neutral. Whatever we do, we are supporting some set of cultural, epistemological, and ideological norms to the detriment of others. Too many practitioners today assume that their role is technical and therefore act in service of unjust power structures without even realizing it. I strongly encourage practitioners to facilitate rather than applying off-the-shelf solutions. These interventions can and should be expressly political rather than trying to follow quote-unquote technical standards, actually just universalizations of the values of certain privileged groups. Thank you.
Thank you, Teo. You've activated actually excellent presentation, first of all, and thank you. And you've actually stirred the pot enough to have some chat stuff going on. So you've got some questions. Yeah. So I'm going to start with Professor Handy. She says, Teo, regarding your first example, this makes me think about the takeover of streets in the US that has been happening under COVID. What do you think about this trend? Is it an example of reinvesting our formal infrastructure with cultural meaning?
Absolutely. So first, I'll just clarify that I'm not in the US right now, so I'm still in French Polynesia writing my dissertation. So I haven't seen firsthand, but I've seen pictures and I've heard about it from people. I definitely think it's great. And I would definitely categorize that as an instance of people developing mobility cultures that are adapted to local needs and contexts. So I think it's great. And I think it's definitely an example of the sort of thing that we should be doing moving forward.
And since you're in French Polynesia, did you say? It is only through technology that we have you here today, right?
Absolutely.
Okay, I have another question. This is from Sue Dexter. Modern transportation need to flow many, many people in a short time over space. How can we utilize these concepts in major urban areas?
So I guess I would actually start by interrogating some of the premises of the question. Do we need to move large numbers of people over large distances of space? So obviously transportation is not an independent phenomenon. It relates to things like settlement patterns, land use, culture, economic structures, et cetera. But you know, I could see a future where Los Angeles is more like a constellation of villages, and maybe people don't have to travel from one side to the other side of the region on an everyday basis. That could be more of an extraordinary thing. And you know, we can actually develop and give meaning to space in new ways that make actually spaces seem bigger. A lot of it is actually caused by modern transportation. So the speed of transportation makes places seem smaller than they are, which is what creates the expectation that we should be able to travel move large numbers of people around large distances. So there's a question about extractivism. Someone said they would like to understand this more, and if I can expand on that. So if you're interested in learning more about extractivism, I would recommend Naomi Klein's book, This Changes Everything, because it's really well written. It doesn't require any prior specialized knowledge, and it explains everything in great detail and in a lot of with great clear examples. But basically, extractivism is about extracting value from sort of others, which are cast as resources, like nature or people in developing countries or poor people, historians. This is like unpaid labor of women, as well as fossil fuels, mining, and so forth. And so basically you extract that value, and then there's a way in which that value is channeled to very small sections of society. And then there's like that waste is then again imposed in those areas that are also extracted from. So it's like just a way of sacrificing certain sectors of society and nature in order for some people to gain more wealth. Yeah, so that's what extractivism is.
From Susie Pike, great presentation and very interesting. What do you think about the sort of cycle nature of infrastructure and use of systems informing cultural expectations, promoting particular planning practices and so on?
Absolutely. It is cyclical, right? These things all reinforce each other, like education, research, practice, infrastructures, the way we interact with those infrastructures. They all support each other. And so that's why we end up in the situation where we're like actually oblivious to other possibilities or other ways of thinking because we keep getting reinforced in that system. And so it actually took me a while to hit on this. And that's why I think the lens of epistemology is really important, even though it's kind of first, because it's really about like ways of knowing. And once you start looking at other ways of knowing, then you can start to change the way you think and change your ideas and like develop new creativities, which then can like break that cycle or help to like appropriate or modify that cycle in productive ways. And the other thing about epistemologies is that, so I spoke to a Hawaiian scholar, Manulani Maier, before I started my research in French Polynesia, who warned me that taking even a good idea from one place to another is neo-colonial. So it's like, even like something that works great in Tahiti or wherever, like you shouldn't just do that in California because it's based on local context. But the thing about epistemologies as like a way of knowing is portable. So you can copy, it's not good to copy an idea, but it's great to copy an epistemology, if that makes sense. So I see a comment from Sequoia Riley. So she said that it sounds similar to what she's read about Native Americans within the US, how they're very much connected with nature. So yes, and actually this is part of modernity coloniality in a sense that we have always been connected with nature and part of nature, but within the modern scientific framework, that like separation between the observer and the observed has led us to imagine that we're actually separate from nature, where we're actually not. But it's like a very particular situation that has never previously existed in human history. And that's why we're in the situation where we're like creating catastrophic climate change, because we have this like mental colonization that we're separate from nature. And so indigenous peoples have never thought that. And it's only this global Euro-modernity that has brought that along.
So if you were king, where would the first steps be in terms of transportation policy?
Oh gosh, that's an amazing question. It's like a really big question. I haven't actually thought about that. Like, what would actually the first steps be? But I think in terms of process, it's not about like one person saying what we have to do, but it's actually about changing the process and making it like a process of collaborative and collective awakening, collaboration, forging new relationships mutually based on each of our knowledge. And it's also about diversity. So it's not about like, you know, one person's perspective being able to say like, okay, this is the way we should do things, but it's actually like all of us connecting with our own experiences and perspectives in reflective ways, and then like communicating those to produce a diversity of different epistemologies and different like transportation solutions. But I think I guess one way that would be like fairly straightforward within the current context is again focusing on facilitating like diverse mobility cultural practices, like taking over streets or like loosening some of the rules that, you know, restrict how people can move. It's hard because so much of it is like integrated with capitalism. But yeah, my postdoc project actually is going to be focusing on developing specific policy recommendations and specific planning interventions, like in terms of different types of infrastructure. So I might have more for you in like a year or two, but for now, that's like how I think about it.
Okay, that's a fair answer. Sounds good. Let's see, we got another question from Sue, who's asking for recommended readings for changing our mental state in this fashion.
Yes.
I'm fascinated and curious by what you have said.
So let me just share my screen. So I have a brief selected bibliography. I can share this as well as the Naomi Klein reference. And I guess we can probably send it by email maybe. But it's kind of like what I've relied on here is a mix across different disciplines. So that's like another thing about diversity is like I'm using epistemologies from different disciplines. So I have like Indigenous studies, I have feminist studies, I have science and technology studies, I have futures studies, I have Latin American studies, post-colonial studies, anthropology, environmental humanities, environmental studies, things from lots of different places and putting them together. And I guess, yeah, I've done the work of like putting together some relatively concise readings. So I'd be happy to share that in written form with folks.
Okay, well, Teo, you have gotten us off to a really interesting start. You got people thinking, you woke everybody up. That's all great. And I think the challenge will be for the next session, right? To to figure out what's next. And maybe we have a debate at the end of, where we all fall on your scales from your arrows on your charts from one extreme to the other. And who should be moving where as a way of improving the system. We should all thank all of our speakers, all of our 3 panelists from the morning session. They got us off to a great start. So you see what I mean when I say we've got the best of the best here. And we will continue to have some interesting presentations in the next session. So have a good break and see you all at 11.